All right, everybody, we're continuing our discussion of multiple choice for the final exam. And here we are. We got a little interrupted with pizza, but we're back. Okay. What is the product of the following reaction sequence? If equal amounts of two products are your predictions, then shade in both products. And this is a sneaky way of having more than 4 answers, isn't it? It's going to happen a couple times in your test. You'll notice there's another, I think 1 or 2 other questions that will have you possibly shading more than 1 answer, and it will say to, don't ever shade more than 1 answer if it didn't ask you to, as a possibility. Okay, nor your intention is to shade 1 answer for every question until you're told you can do otherwise. All right, so TSCl and pyridine. That's how you make a tosylate ester. So step 1, and you got to remember the stereocenter does not change during that reaction. The O attacks the sulfur, so the O stays in the same place. And just in case you're curious, you don't really have to draw this out, but there's what the ester looks like, toluene sulfonate ester. And now you have a secondary RX, which is helpful because you're hitting it with a strong nu. That's an SN2 thing, right? And a polar A product solvent, also an SN2 thing. And it's a final exam. I'm not going to have crossed messages in one of the things. I'm not going to have one saying SN1 and the other saying SN2. No, won't happen. I apologize. I could take that back. If it was a tertiary RX, I don't care what the other 2 things are. How's that? Now I could have crossed messages there. You're not changing your answer. You're going to go with SN1 if it's a tertiary RX. If it's a primary RX, I could have a weak nucleophile and a polar product solvent. You're not going to make a primary RX undergo SN1. I don't care what you do. There's no primary carbocation. But here I've got something that says I don't know, and I got the SN2. So azide is your guy. And you just need to know that this started out as an S stereocenter. So whatever you're going to get R on carbon number 1, 2, 3, 4. The oxygen's going to be gone, so that's why my nomenclature prioritizes the alkene. Clearly, azide is going to be on carbon 4 or 5 in this question, and 5 is not a good choice. 5's for the students who numbered it backwards, who went 1, 2, 3, 4, 5 and didn't use the right nomenclature. And it's going to be R, not S. So C. You want to do this one fast, yeah. And the next guy is what's the only product formed in the following sequence? What are we going to get here? R4-methyl-1-hexene. 1-hexene, 2, 3, 4, 5, 6. R would be H here, O here, and BH. What? What did I do that for? No. I was thinking ahead. I saw BH3 and I got carried away. There's no alcohol in this thing, right? It's got a methyl on 4, and that would go 1, 2, 3. I need the H here still. And I'm kind of wasting your time anyway, because the stereocenter doesn't change. There's no reaction happening over there. So, the reaction's happening at the end where the alkene is, right? So there you go. Alkene, step 1, BH3, step 2, anti-Markovnikov alcohol. Got to know that. And, here, Should have done this from the beginning, right? Nothing changed over there. And we have to know PCC converts primary alcohols to aldehydes, not ketones, not carboxylic acids. I'm going to make choice C the right answer in a different question when I'm done. I anticipated her question. But yeah, we're making aldehyde. So I'm just going to say 3 goes to aldehyde. And that's the answer. And change 3 PCC to 3 CrO3, H2SO4AQ, or K2Cr2O7, H2SO4AQ. Now, answer C is correct. That's how you make carboxylic acid from primary alcohol. There you go. We're revealing all the tricks.
If it was internal.
If it's internal, yeah, if I changed number 1 and 2, here, change reactions to, this is good. This is really good. 1, HgOAC2 H2O, 3 to 3. 1, 3. 2, NaBH4, and 4, 3, 3. I can't count today. PCC or CrO3 H2SO4 AQ or K2Cr2O7 H2SO4 AQ. Answer is now B for any of those possibilities. I covered all the possible changes I could do to this question to make any of the answers the right answer. Because in step 1, you're putting a mercury on the less substituted carbon and the OH on the more. Step 2 gets rid of the mercury, puts an H in its place. And 3, oxidizing any secondary alcohol gives a ketone. Fact. All right. There you go. Oh, that was good. Stop that one.